Hi, today's lesson is on polynomial identities. There are four main polynomial identities, which is the difference of a square, sum of a square, difference of cubes, and sum of cubes. So these are just special cases that show up a lot. And using this, you can use a lot of shortcuts to just get past it real fast. So for example, if I see something like this, x squared minus 4, it's in this form. It's a square minus a square. So all we have to do is write x minus 2, because that's 2 times 2 is 4, and x plus 2. That's it. So for a sum of a square, same story. If I have x plus 3 squared, the way you multiply this out quickly is you go x squared, do 3 times x, and then double it. So we get 6x, and then 3 times 3, which is 9. So for difference of cubes, we look for cubic numbers. So first thing we do is we write without any cubes. So we go x and then minus 3, because 3 times 3 times 3 is 27. Now using this, I can write this part. So x times x is x squared. Do 3 times x and change the sign. And then 3 times 3 is 9. And that's how it works every time. So same thing, one more. If I have x cubed plus 64, I get x plus 4. So then I get x squared minus 4x plus 16. And that is a pattern. So basically in math, any shortcut we find is basically just a pattern. It's nothing more. So here's my question. How can I prove this to be true? Well, the easiest way is just to go ahead and multiply this side and see what happens. So I'm going to first multiply everything by a. That'll give me a cubed plus a squared b plus ab squared. Now if I multiply everything by negative b, I get negative a squared b, negative ab squared, and then negative b cubed. If you notice, these cancel out. So you have a cubed minus b cubed. And that just proves that those are true. So how do we use these polynomial identities? Basically what we do is we look for the form and then we see if it works. If you notice, this is just a square. So all we have to do is square the first one, which is 9x squared, multiply these together, which would be negative 15x, and then double it. So we get minus 30x, and then we square the last one, which is plus 25. So let's try it again, but now with exponents. So we go 2x squared times 2x squared, which is 4x4. Multiply these together, 2x squared y cubed, double it, plus 4x squared y cubed, and then square this one. Now the way you square exponents, you just multiply them together. So this would be plus y to the 6th. Try this problem. Okay, now we're going to use polynomial identities to factor and simplify. So these are the difference in squares, difference in cubes. So if you notice, these are square. How do you know? Because these are even. 4 and 6 are even, so they're square. So this one becomes 3m squared minus 5n cubed. And the reason we get cubed is because it's a square, we half it. We half the exponents, okay? And now we just copy again, 3m squared plus 5n cubed. So a better example of this is if you have like x squared minus 100, you just write x minus 10, x plus 10. If you can identify these quickly, it saves you so much time and just frustration. So now with the cubes, this is a cube number. You give it away, it gives it away with the 3 right there. So we write x minus 6, because 6 times 6 times 6 is 216. So from there, we're going to use this to write the rest. So x squared, 6 times x is 6x, and then 6 times 6 is 36. That is the pattern it follows, and it works every single time. So here's another one we could do with numbers too, with the cubes. So this one's actually a lot easier because they already give you the numbers. So we go 11 plus 5, keeps the sign. Now we go 11 times 11, which is 11 squared, or 121 if you want. Multiply these together, so minus 5 times 11, or 55, plus 5 squared. And that's the pattern it goes. Okay, you can go from there and find all the numbers and everything, but honestly, you just use a calculator and you wouldn't waste your time. Go ahead and try this problem. Try this problem. Try this problem. All right, let's talk about expanding a power of a binomial. So basically, what happens here is you can multiply these out over and over and over again. So I'm going to show you just the pattern in it instead of showing you the tediousness of multiplying. So let's go ahead and start with this one. We know if it's x plus y squared, you get 1x squared plus 2xy plus 1y squared. And I'm writing the ones on purpose. If you do x plus y cubed, in other words, we're going to take this right here and multiply it by x plus y again, we get a whole mess of the thing, okay? But basically what you end up with is 1x cubed plus 3x squared y plus 3xy squared plus 1y cubed. And then it just keeps going from there over and over again. If you notice, there's a pattern with these numbers, okay? If you do x plus y to the fourth, I'm going to show you a little bit different. You end up with 1, 4, 6, 4, and 1. And then you go x4, x3, x2, x, y4, y3, y2, y, and nothing. Since it's plus, they're all plus. This is how you expand a binomial. So what this happens to be is it's a nice pattern that it follows. If I start with a 1 and I write 1, 1. If I notice, if I keep going 1 down the diagonal, what's 1 plus 1 is 2. Down this is 1. Do a 1 on the diagonal. 1 plus 2 is 3. 3, 1. Keeps going. 1. This would be 4, 6, 4, 1. And if you notice this pattern, it makes a triangle, and it follows here. This is exponent of 2. This is exponent of 3, exponent of 4. The number here matches it. So basically, if you notice, these are just expansions of each other. And using this, we can write any binomial, just using the pattern I kind of showed on this one, but I didn't talk about. But now I'll go ahead and talk about it. How do we do this? Well, we notice to the fifth, we're going to just write Pascal's triangle. But since I already wrote most of it, I know it's after 4, which is 1, 4, 6, 4, 1. All I got to do is expand that. So this would be 5, 10, 10, 5, and 1. Because these two, these two, these two, these two, like that. So now that I know this, I can expand this one. So first things first, to write the expansion, I write these numbers with some space. 1, 5, 10, 10, 5, 1. And now I'm going to go ahead and start with x5, count all the way down. So x to the fifth, x to the fourth, x to the third, x squared, x. And now I'm going to do the countdown with y, but backwards. So y5, y4, y3, y2, y, and then nothing. And since it's plus, we write plus, 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 plus. So what we do here is now we just clean it up. So we go x to the fifth plus 5x4y plus 10x cubed y squared plus 10x squared y cubed plus 5xy4 plus y5. So let me give you one more example to help you out. But what happens if it's negative? I'm going to do this with the 4s. So I'm going to say x minus, we'll go with 2 to the 4th. So same story, we look for 4. It's 1, 4, 6, 4, 1. So 1, 4, 6, 4, 1. And now what we do is same thing. x4, x cubed, x squared, x. Now on the backside with the number, we're going to go ahead and use it with the 2. So this would be 2 to the 4th, 2 to the 3rd, 2 squared, 2. Now, how do we deal with the minus? Well, there's a trick to it. If you start with minus and go back and forth, you'll get it right every time. So minus, plus, minus, plus. And then from there, we can clean that up. So this would be x4 minus 8x cubed plus 24x squared minus 32x plus 16. And that's how you go about doing this. Try this problem. Try this problem.